Good afternoon. I apologize for not being able to attend the conference physically due to some health issues. This is a presentation for the research study entitled "The Sustainable Potentials of the Multi-Angled Facade System and Their Alignment with the UN Sustainable Development Goals." This research is conducted at Middlesex University in London. The design concept of the multi-angled facade is a three-dimensional facade that extends outward from and is connected at its sides to the original building flat facade. The target is the use of two differently orientations of windows in each facade to optimize the use of solar radiation and daylight through the facade. The large part of the multi-angled facade is oriented more to the north to optimize the use of daylight, and the small part of the multi-angled facade more to the south to optimize the use of solar radiation through the facade. This is combined with the appropriate use of window glass properties and solar shading control system. The objectives of the research study to define the suitable glass properties for the two windows of the multi-angled facade. This is in order to evaluate the impact of glass properties on the energy performance of the multi-angled facade and the building's indoor climate. To conduct an embodied energy analysis for the multi-angled facade's materials and to compare it with a flat facade. So as a background, windows with 3 layers of glass have a lower U value compared to 2 layers of glass, but this has an impact on the G value and light transmittance, which also will be lower. Energy windows with 3 glass layers can have a glass U value between 0.5 and 0.7 watt per square meter Kelvin. G value between 0.5 and 0.61, and light transmittance between 0.71 and 0.77. By increasing the glass layers thickness, the numbers, and by adding coating for the glass layers, the G value and light transmittance will be lower, but in different degrees. The types of coating and its placement inside the window cavity can control the relation between G value and light transmittance. A model for a room with inner dimensions 5 multiplied by 4.5 multiplied by 3 meters located in Copenhagen is built in the software program EDA's version 4.8. The heating system consisted of water-based radiators and the energy source is district heating. The mechanical ventilation system was variable air volume only during working hours between 8 and 17, in addition to mechanical night ventilation. The facade opaque part was U value of 0.125 watt per square meter Kelvin. External Venetian blinds are used in both parts of the multi-angled facade system. The small window shading system depends on the operative temperature, and the large window shading system depended on solar radiation intensity. This study modeled 5 scenarios for a multi-angled facade with different glass properties in both parts of the multi-angled facade. To compare the impact of the glass properties in the 5 scenarios, the window glass type in the large part of the facade was the same in scenario 1, 3, and 5, while the glass type in the small part were different. Moreover, the window glass type in the small part of the facade was the same in scenario 1, 2, and 4, while the glass type in the large parts were different. This helped in comparing the impact of the glass properties in scenario 1, 2, and 4 with a greater focus on daylight efficiency and heat loss, higher light transmittance in the large window part. This also helped comparing the impact of the glass properties in scenario 1, 3, 5, with an increased focus on the heat gain and heat loss, higher G value in scenario 1 and 3 in the smaller window part. Regarding the method for the embodied energy analysis, the software LCA Book version 5 is used. LCA Book supports consideration of a large part of buildings' life cycle according to the EN 15978 standards for the life cycle analysis for buildings. Regarding the results for the energy consumption and indoor climate, the results of the simulation of the primary energy consumption for the 5 scenarios are shown in the figure to the left. It can be seen that the total primary energy consumption for scenario 2 is higher than the others. The number of overheating hours inside the office room for the 5 scenarios are shown in the table to the left, where scenarios 1, 2, 3, and 5 fulfill the Danish legal. The average illuminance in looks at the occupant location in the 5 scenarios is shown in the figure at the bottom right. In January, the values are slightly higher in scenario 1, 2, and 4 compared with scenario 3. In May or July, the illuminance is higher in scenario 2 and 4 compared with the other scenarios. The average heat gain from solar radiation in watt and heat loss through transmission in watt and their sum through the 2 multi-angled facade windows in the 5 scenarios are shown in these 3 tables. In general, the heat loss is more stable value compared to the heat gain, as the latter is more changeable from a period to another during the day, depending on the solar shading control system and changes in the weather conditions, particularly whether it's cloudy. The highest value for the heat gain is in the small window part in scenario 3, owing to the high G value compared with the other scenarios. Regarding the results for the embodied energy analysis, the embodied energy related to the components or materials through the different phases of the facade components life cycle are shown in the table to the left. The embedded energy calculation for a multi-angled facade system and for a flat facade is shown in the table to the right. The total energy consumption throughout the building's lifetime and embodied energy calculations for the multi-angled facade and the flat facade and the sum of both, not area weighted, is shown in the figure to the left. Comparing the area weighting of the sum of the previously mentioned values is shown in the figure to the right. This value is higher when the renovating with a flat facade by about 11% compared with renovating with a multi-angled facade. The same value is higher with no renovation by about 87% compared with renovating with a multi-angled facade. For the discussion, in general, all glass types in these 5 scenarios are three-layer glass with argon gas fill and low emissivity coating. Therefore, the differences between the results are not high. Regarding the light transmittance property of the glass, scenario 2 and 4 have the highest values, which has an impact on reducing the electrical lighting energy consumption. Scenario 1 and 5 have close to the lowest U value in both parts of the facade, which has a positive impact on reducing the consumed energy for heating. Regarding the thermal indoor climate, the number of overheating hours inside the office room for scenario 1, 2, 3, and 5 fulfill the Danish requirement. It's important to consider the values of both the heat gain and heat loss and its impact on the energy consumed for heating and mechanical ventilation. The total sum of the heat gain and heat loss in January on both window parts of the multi-angled facade in scenario 4 is the lowest compared to the other scenarios. This has an impact on the energy consumed for heating, which in scenario 4 is the lowest compared to the other scenarios. The high G value in the large window part in scenario 4 impacts the energy consumption for mechanical ventilation, which is the highest in scenario 4. By looking at the average illuminance value in May or July, where the positive impact is more from the large window oriented more to the north, the illuminance is higher in scenario 2 and 4 compared with the other scenarios. Regarding the discussion for the embodied energy analysis, the area weighting of the total energy consumption through the building's lifetime and embodied energy is higher when the renovating with a flat facade by about 11% compared with renovating with a multi-angled facade. The area weighting of the sum of the total energy consumption throughout the building's lifetime and the embodied energy is higher with no renovating by about 87% compared with renovating with a multi-angled facade. So as a conclusion, as a result of analyzing the 5 scenarios and considering the pros and cons of each scenario, the researcher recommends the glass type in scenario 1 because the better illuminance. It also offers lower total yearly energy consumption and the accepted number of overheating hours inside the office room. The calculation of the area weighting of the sum of the total energy consumption through the building's lifetime and embodied energy is higher when the renovating is with a flat facade by about 11% compared with the renovating with a multi-angled facade. This result indicates that the multi-angled facade is a sustainable solution and is more environmentally friendly than using a flat facade. Thank you.